Good morning. Good morning and welcome to America's Rocket Factory, NASA's Michoud Assembly Facility. My name is Robert Champion. I'm the director from the Michoud Assembly Facility here in New Orleans, and we're very pleased to have you here this morning. It was just to celebrate a very special event, Artemis Day. It's a privilege to be leading this unique facility at such an important time in NASA's future and history as we prepare to send Americans astronauts back to the moon in 2024. Michoud is proud of its nearly 60-year history in manufacturing and assembling large vehicles and components for our nation's space program. From the Saturn era to the shuttle program to today's Space Launch System and Orion spacecraft. And today you'll see firsthand how impressive this work here is going on at Michoud. This morning I have the honor of introducing someone who is no stranger to Michoud's accomplishments and contributions over the years. After spending a significant portion of her 34-year career with NASA in the Space Shuttle Program Office, please help me in welcoming Marshall Space Flight Center Director Jody Singer.
So good morning, welcome. On behalf of Marshall Space Flight Center, we welcome you to Artemis Day. This is truly a big moment for us. It is a big moment for our team and for all who have worked so hard to get this rocket ready. It is great for you to be here, and we welcome you to be able to be here and share the opportunities with us to see and let us show you what we do. I love it when we're able to celebrate all of our major milestones and minor milestones, which make a huge difference as we're going forward to the Artemis program. So I'm really excited. Not only does this mean a lot to our team, it means a lot to our family members and a lot of the greater community of many of you that are here to help support us, and we really appreciate you. Through the Artemis program, the Space Launch System rocket, the SLS, the most powerful rocket ever built, will send the Orion spacecraft and the first woman and the next man to the moon. So today we are here to celebrate a huge step forward for the Artemis program. Events like this truly underline our commitment in achieving our common goal. I am excited to say that we have representatives here from almost every NASA center, from many of our states and our congressional support. We thank you so much. I hope you have the opportunity and will take the advantage to learn more about what we do at NASA, from the sites and capability of the Michoud Assembly Facility here we're in, to where we're doing on exciting exhibits that we have to show you off the technology and the capabilities for the future that will hugely make a difference as we go further to the moon and beyond. The science, the technology, and the people, and their passion, as well as their exceptional talent, will make a difference. And hopefully you will see the amazement and the proudness that we have of each and every one of our team members. So once again, I would love to thank you all for being here. We especially appreciate all of our employees, the lawmakers, the industrial partners, media, academia, all who have shown up to make part of history. Together, we will make it together. And we will be turning the next page of history, and I look forward to being a part of it. I'd also like to recognize one of our newest members of our team, the agency's new Associate Administrator for the Human Exploration and Operations Mission Directorate. That's a mouthful. We call it HUMD, Douglas Lavero. Just wave your hand, please. So Doug, we're proud to have you on the team and proud to have you down here. So I'm also glad to have a strong administrator who is leading us as an agency through this critical next chapter. His commitment to human spaceflight is evident in his career as a pilot, as a passionate congressman, and now as he leads us, NASA, into the new golden age of human exploration. I look forward to hearing from him, and it's an honor to introduce him, our NASA's 13th Administrator, Jim Bridenstine.
Go SLS. Core stage complete. And I know there's a lot of people here that I need to thank, not the least of which are the men and women who work day in and day out to get us to this point, which I know has not been easy, but we are there. So here's what I want to do. I want to start by thanking some of our elected representatives. Number one, we have here Congressman Randy Weber from the state of Texas. So a lot of people might not know this, but Randy and I were classmates when we came into the U.S. House of Representatives together. One of us was from the state of Oklahoma. One of us was from the state of Texas. But I'll tell you, he became a really good friend. We sat next to each other on the Science, Space, and Technology Committee. We might have been bored from time to time and played a game of hangman or two. But you should know this. We passed some very serious legislation that puts the United States of America at the forefront of space exploration. And because of the legislation that we worked on together, including the NASA Transition Authorization Act, the United States of America is going to lead in space again. And this today is evidence that that is happening. So thank you for being here, Randy. We also have here today State Senator Sharon Hewitt. Thank you for being here. State Representative Ray Garofalo, thank you for being here. And of course, Mayor Greg Cromer from the city of Slidell, thank you for, and he just gave me a key to the city, just so everybody is aware. So I can go wherever I want in Slidell, is that right, Mayor? All right, that key opens every door in Slidell. And I also want to thank so many people that are here, staffers, for members of Congress and senators, key appropriators, key authorizers. Thank you for being here on this very important day when we get to announce core stage complete for, in fact, the SLS rocket, the first step towards achieving Artemis 1, where we get to send the first woman and the next man to the moon. And by the way, that's Artemis 3, but Artemis 1 is the first step to achieving that. So it's great to be here today. A couple of things that are important to remember what we're trying to achieve. Think about this. We have a directive from the President of the United States to go to the moon sustainably. In other words, this time when we go to the moon, we're actually going to stay. We're going to learn how to live and work on the surface of another world for long periods of time so we can take that knowledge to Mars. This time when we go to the moon, we're going to go with international partners, and we're going to go with commercial partners. We're going to learn how to live and work utilizing the resources of the moon. Hundreds of millions of tons of water ice on the south pole of the moon. The water ice represents life support. It's air to breathe. It's, of course, water to drink. But it's also, if you can imagine, rocket fuel. Hundreds of millions of tons of hydrogen on the south pole of the moon. And by the way, the rocket standing behind me, I should say the rocket laying on its side behind me, the SLS rocket is powered by hydrogen fuel, just like the space shuttles were powered by hydrogen fuel. And it's available in hundreds of millions of tons on the south pole of the moon. So we're going to get there. We're going to learn how to use that capability to live and work on another world for long periods of time, and we're going to take that knowledge to Mars. Friends, when we think about this architecture requires the best of everything America has to offer in the terms of space exploration. So of course we have to be able to launch humans. The SLS rocket and the Orion crew capsule and the European service module are qualified. From day one, qualified. Every component, every subcomponent tested and retested to be qualified to launch humans. And when we go to the moon in 2024, it's only going to happen because we have a qualified rocket on day one. The SLS rocket, the Orion crew capsule, the European service module are those elements. So everybody here is aware. The Orion crew capsule and the European service module have now been mated. And they're up at the Glenn Research Center in Ohio being tested with all kinds of acoustics and vibration, thermal vacuum, all the testing that it needs to do to be ready to go to space right now. And now that we have that element complete, and of course we got the core stage complete, we are making significant progress towards achieving that Artemis 3 mission and getting our first woman and next man to the south pole of the moon in 2024. Thank you all so much for all the hard work that you in this facility here at Michoud, America's rocket factory, thank you so much for your hard work. So the rocket and the crew capsule are going to take us to the gateway. When we think about the gateway, think of a small space station in orbit around the moon that gets us more access to more parts of the moon than ever before. It's going to have on it solar electric propulsion. A lot of people don't realize when we went to the moon in 1969, and we did a total of 6 missions up until 1972, we went to the equatorial regions of the moon. And because of that, we assessed, from going to the equatorial regions, we assessed that the whole moon was just like the equatorial regions. And because of that, we missed the fact that the moon has hundreds of millions of tons of water ice on the South Pole. Well, that was discovered in 2009. And from that moment forward, we should have immediately shifted the focus to get to the surface of the moon and learn how to use that as a resource. But now that we have the Gateway, which the SLS and the Orion crew capsule will take our astronauts to the Gateway, we're going to have more access to more parts of the moon than ever before. Think of it as a reusable, in other words, a permanent command module that will be in orbit around the moon for 15 years with solar electric propulsion, so it can go to the North Pole, the South Pole, in other words, the L1 point, the L2 point, and give us access to the entirety of the moon so that we don't miss these kind of discoveries ever again. The other thing that's important is that when we do have the Gateway in orbit around the moon, we're going to be able to control numerous missions on the surface of the moon all at the same time. Some of those missions could be robotic in nature. Other of those missions could be human in nature. And even better, the Gateway itself is open architecture. The way we do docking, the way we do communications, the way we do avionics, the way we do environmental control and life support systems, all of these capabilities are going to be available on the internet. What does that mean? That means if we have an international partner in the world that wants to build a human landing system that can go back and forth to the surface of the moon, they can join the United States of America in this architecture. That means if we have a commercial partner who wants to build a human landing system to go back and forth to the surface of the moon, they can do that. If there are companies that want to have robotic capability on the surface of the moon, maybe have a commercial astronaut at the Gateway, maybe international partners at the Gateway, to control those activities on the surface of the moon, they can do that. Here's the thing that's important to note. Because of the capability behind me, the SLS rocket, the Orion crew capsule, and the Gateway, we are going to take the lead. And we're going to take a coalition of nations to go to the moon, this time to stay. And that is a significant difference between what we're doing today and what we did back in 1969 through 1972. We are achieving sustainability with commercial and international partners, and of course, the most powerful rocket ever built in human history, the SLS. Qualified on day one to fly our humans to the moon. A couple of other things to note. When we talk about the Gateway, when we talk about this architecture, it is going to enable us to do more science than ever before. A lot of times people say, you know, and I hear this a lot, there's this false narrative, sometimes perpetuated on the Hill, that maybe every dollar we spend on human exploration is a dollar that we don't spend on the Science Mission Directorate. But when we build the Gateway in orbit around the moon, the Gateway is going to have a communication architecture associated with it. Let me see if I try this, if this is better. I guess not. The Gateway, test 1, 2, test 1, 2. The Gateway is going to have a communication architecture. The communication architecture enables scientific missions on the surface of the moon, maybe on the far side of the moon, in orbit around the moon, to do astrophysics, planetary science, and heliophysics in a way that otherwise would not be possible. For example, there's a mission I'm very keen on called DAPPER, where from the far side of the moon, where it's extremely quiet, from an electromagnetic spectrum perspective, it's extremely quiet. We can see not just out into space, but we can in fact see back into time. Not just the first light in the universe, but we can actually see after the Big Bang, before first light occurred, we can see those dark ages. And we can only see that from the far side of the moon. And by the way, that mission called DAPPER that would be in orbit around the moon to give us that beautiful data and information, that specific mission would normally cost $500 million, $500 million. But because we're going to have a communication architecture at the moon and we don't have to launch these large aperture antennas for communications. We can get high throughput data down to Earth quickly. All of a sudden, that mission goes from $500 million down to $90 million. In other words, we can get a whole lot more astrophysics, science, and information than we could ever get without having this architecture on the moon. The other thing is, on the far side of the moon, we can actually collect very low frequency signals, not just from out in space, but also from back in time. And we can get really good data on what the first light in the universe actually looked like. You know, as the universe has expanded, that was light back in the day, and today it's very, very low frequency. And we can pick that up with antennas. When I say antennas, I'm talking about wire antennas on the far side of the moon, where it's not perceptible for us here on Earth, but from the far side of the moon, where it's very quiet, we can get this data on the first light in the universe. My point is this: whether we're talking about astrophysics or heliophysics, the study of the sun, the moon is a repository of data and information of the early solar system. Subatomic charged particles coming from the sun have been hitting the Earth for billions of years at this point. Billions of years, which means the regolith is data from the early solar system. We can make assessments as to what the early sun was like based on the regolith on the surface of the moon. And all of this science and all of this knowledge and all of this capability is going to be available to us because we are launching humans to the moon for the first time since 1972. So I want to say thank you to all the men and women who have worked so hard to get us to this day where we are ready to take this rocket, the SLS rocket. By the end of the year, we're going to be moving it out of the Michoud Assembly Facility. Think of it as NASA's Christmas present to America, and it's because of you. We're going to move it out of this facility. We're going to take it to the Stennis Space Center. We're going to do a green run test. We're going to prove its capability. We're going to get it to the Cape, and we're going to be ready to launch American astronauts to the moon again, and we are so excited about this opportunity. So with that, I'm going to open it up to a few questions, and then we'll close it out.
So we're going to take questions from the accredited members of the media. When you ask a question, please say your name organization. Please limit to one question per outlet. And then we're going to do a few minutes, and I'll call last question in a few minutes.
Hi, I'm Paul Brinkman with United Press International. So you talked about how this is the most powerful rocket ever built and that the having architecture on the moon would lower costs dramatically. So this rocket is not reusable, though, correct?
That's right.
So at what point would NASA consider moving toward reusability in a moon and Mars rocket?
Very soon. So what this rocket enables us to do is launch the Gateway, which is a reusable command module in orbit around the moon for the next 15 years. But more than that, it also enables us to take our astronauts to the Gateway where they can get into a landing system and go to the surface of the moon. At the same time, when we talk about this architecture in its entirety, there are other rockets that we believe one day will be available that aren't necessarily qualified to take humans, although maybe one day. But I think in short order, they'll be ready to take cargo. So maybe they'll be able to launch a landing system that we can aggregate at the Gateway. And then that landing system can take our astronauts back and forth to the surface of the moon. By the way, that landing system also, the goal for sustainability is have the landing system itself be reusable. Again, remember, we go back to Apollo, it was not sustainable because the cost was too high, and it was too high because everything got thrown away on every mission. So what SLS allows us to do is ultimately have sustainability to launch the capabilities that will in fact be reusable, but it itself isn't reusable. But you got to remember, what is it launching? It's launching the Orion crew capsule, and we would like to see the Orion crew capsule have elements of it be reusable really by Artemis 4, by the fourth launch of the Orion crew capsule. So parts of this rocket will be reusable, I should say, more so than in the Apollo era. But the architecture that it's going to be able to deliver is the key to the sustainability aspect. And by the way, those heavy lift capabilities, this is a unique rocket capable of doing all of that activity.
Jeff Faust, Space News. When do you expect to have an updated launch date for Artemis 1?
Well, that's a good question. And in fact, this gives me a great opportunity. We have a new associate administrator for human exploration and operations. And of course, I have said, we've had the date out there that we would launch Artemis 1 in 2021. And of course, I want to make sure that before we put a hard date on it, I give our new associate administrator time for him to do his own assessment, his own evaluation, put together people that he's comfortable with, people that he trusts to do an assessment, and then make that determination and come back to me. Now, the goal here is ultimately to be realistic about our projections, but our goal is to launch the first woman and next man to the South Pole of the Moon in 2024. So with that, Doug, if it's all right, I'll bring you up on stage. I'll give Doug Lavero an opportunity to address a lot of his new workforce, because a lot of you here now work for Doug Lavero. So Doug, thank you. And tell us, if you would, Doug, as I turn the mic over to you, tell us about your pin.
Well, first of all, thank you everybody for welcoming here today. It has been fantastic meeting all of you today. Now, I have to promise you, as many of you have heard me say, I will forget every name that I've heard this morning, and that is a solemn promise. I will absolutely live by that. But eventually, I hope to go ahead and get to know you all, because you guys have made this wonder. I'm going to call it the ninth wonder of the world right now. I'm going to call this the ninth wonder of the world. You guys have made this wonder happen. And that is absolutely fantastic. And you all ought to be justifiably proud of yourself. So we need to give you a round of applause again for that. Now, the boss already told you everything that I could possibly want to tell you about this rocket and where its place is in history. I won't go repeating that. But he asked me to talk about this little pin that I'm wearing. This pin today says 1,849. When I was sworn in back last week, this pin said 1,856. That's the number of days left before the end of 2024. And we will put the first woman and the next man on the moon before this pin goes to zero. Absolutely 100% guaranteed. And I will tell you, starting next year, right after the beginning of the new year, in each day of that on our countdown, we will highlight one hero, and we're calling it the Hero. We will highlight one hero, and that will be your day. And you're going to tell us what you made count that day, what happened that day to help us in our quest. And I don't care where you are in this program, every one of you is doing something critical, and we will highlight you for that day. So think about that as we go forward. There's at least 1,849 out there who have something to tell about your story. And we're going to make sure that America knows about your story, because every one of you is getting us to the moon. It's not just the folks on the top of the capsule. It's not just of those sitting in headquarters. It's every one of you sitting in this audience that will get us to the moon. And we are going to go ahead and make sure America knows who you are and what you did to get us there. So with that, I'll turn the mic back over to the boss. Thank you so much, everybody. It's been a great meeting you.
Thank you, Doug. Sorry for putting you on the spot. Thank you. Thank you, Doug. All right, more questions from the media?
Ken Kramer, Space Up Close. Thank you, Jim, for doing this. This is a great day.
Absolutely.
Talk about the landing site. When are you going to select the landing site for Artemis 3, Artemis 4? Do we pre-position equipment there? Do you have teams already thinking about this? Thanks.
We do. One of my first initiatives as the NASA administrator was to announce the Commercial Lunar Payload Services Program, where we can send NASA instruments and, in fact, NASA science capability to the surface of the moon ahead of Artemis 3, ahead of the first humans since 1972 going to the moon. And the reason we do that is we want to be able to characterize the capabilities in different spots, especially on the south pole of the moon. We want to be able to characterize where the water ice is, the cold traps. Obviously, the water ice is going to be in those cold traps in the craters. But we need to know, how is it there? How is it embedded in the regolith? How do we extract it? How do we use it? So that when our astronauts get there, they have very meaningful work to do. So we're going to learn from the Commercial Lunar Payload Services Program kind of where we want to go and what we want to do on that first mission. I will tell you, though, that first mission, we will get outside the lander. We will walk around on the surface of the moon, and we will do meaningful work before getting back into the lander. As far as what that meaningful work is at this point, we're going to find out as we develop the Commercial Lunar Payload Services Program, which, by the way, we've just added 5 more companies to that contract. So we've got now other companies that are capable of taking bigger payloads to the surface of the moon. And of course, some of those payloads could be rovers that could help us characterize that water ice. So that's what we're looking to do in the coming years, ahead of Artemis 3. Thank you.
Space.com. Can you talk about how much it's going to cost to launch each SLS rocket? Maybe why this has been a number that is seemingly up for debate still.
Yeah, so the question is, how much is it going to cost each SLS rocket, and why is that a number that's still up for debate? Well, it's really quite simple. If you buy one SLS rocket, the price is really high. If you buy 2, the price comes down significantly. If you buy 3, it keeps going down. So what we're doing is we're looking at what are the needs that we have over the coming decades, and how many SLS rockets do we need to buy? The more we buy, the more the cost per unit comes down. And that's just a matter of economies of scale, and it's true whether you're buying fighter aircraft or you're buying automobiles. The upfront cost, the development cost, the overhead is the biggest part of any kind of development project. And if you look at any development project, it follows a traditional bell curve. And it go back to Apollo, it was a bell curve. Well, the challenge that we have as an agency right now is that our budgets are flat. We don't get bell curve budgets, we get flat budgets. So we have to figure out, how do we take all of that bell curve money and spread it over so many years? And that, by the way, for our representative that's here, that actually costs the government more money over time rather than the traditional development cost. And so it takes longer, it costs more, and it creates challenges for a program. So we have to think about, when we go forward, how many we're going to buy now that we've gotten to the point where we are ready to take the first rocket out of the assembly facility and test it. But I will also say, as we go through this process, we need to look at the price based on a negotiation between NASA and our prime contractor. And that negotiation and how many we buy ultimately is going to determine what that final cost will be per rocket. But again, remember, the more you buy, the more the cost goes down. So it's a balancing act to make sure we're getting the best value for the American taxpayer.
Hi, Stephen Clark from Spaceflight Now. Thanks for taking our questions, Jim. Given that the human landing system is one of the pacing items for 2024 Artemis 3, can you update us on how close you are to selecting contractors, and is that directly tied to waiting for an appropriation from Congress? Thank you.
That's a great question. We are, of course, interested in an appropriation from Congress, because that will enable us to move forward with a human landing system in the way that's most appropriate for the American taxpayer. It is also true that if we don't get an appropriation from Congress, there are ways we continue moving forward without necessarily having an appropriation. And of course, I can go through some of those ways, but number one is the fact that right now there are companies that are moving forward with the human landing system regardless of the appropriation already. Some of those countries, some of those companies you well know, they've already developed a lot, and they're continuing to develop regardless of our appropriation. So that's number one. Number two, it's also true that we have the Commercial Lunar Payload Services Program already underway, and that's within the Science Mission Directorate. But there is not a reason that those landers couldn't be human capable. So and I'm not saying we're going to do that. I'm saying if we end up in a gridlock position where we have no appropriation, what are the tools available to us to make sure we can keep moving forward so that we can make that 2024 date? That's the goal. And I will tell you that there are other tools. We have, we have these challenges that are put out by the Space Technology Mission Directorate, for example. Well, those challenges are sometimes tied with prizes. So we could actually use prizes to entice some companies to move forward, even though we don't have an appropriation at this point. My point is this, and I need to talk to the lawyers. I'm going to be very honest. I need to talk to the lawyers. But at the end of the day, I think we have already started on human landing systems. If you look at the Next Step program, operated by the Human Exploration and Operations Program, the Next Step program actually had an appendix focused on human landing systems. So you could argue that it's not a new start. So can we actually use the Next Step program to continue the development as well? So I think there are these different, if we don't have an appropriation, we have to get a lot more creative. And of course, we want to make sure that we're doing things within the law 100% all the time. But there are tools that we have available to us to keep moving forward if Congress needs more time and they don't have an appropriation bill. But make no mistake, we want an appropriation bill.
Hi, Kurt Godwin with Spaceflight Insider. Now, I saw that the test article just recently survived a 260% load test at Marshall. And through the construction both of the qualification pieces and the test article and now Artemis 1, have you found any workflow efficiencies, any construction efficiencies, things that you can reduce cost, decrease time to construct for future Artemis missions?
Yeah, great. 2 points, and I love your first one. We tested a hydrogen tank to failure. Was it hydrogen or hydrogen? The hydrogen tank that was tested to failure met 260% of the load. That is really, really good. We're very pleased with that. And just so everybody knows, I want to get the video of that, and I'm going to tweet it out. I think it's really cool. People need to see it. And just so everybody knows, we test things to destroy them so that we're safe. People are like, oh, don't tweet that out because we don't want to see people don't want to see something blowing up. I'm like, no, people want to see things blowing up. That's what they want to see. It just so happens that in this case, it blew up at 260% of the load, which is a good thing. Good thing for our astronauts. Good thing for America. Let's make sure that we're celebrating the fact that this thing blew up at a greater amount than we ever thought it would blow up. So that's good. All right. So with that, the other question, what was your second question? Workflow efficiencies. Okay, this is awesome. So the SLS core stage complete. That's a beautiful, beautiful sign. Just so you know, a year ago, I was getting called to testify on the Hill because this vehicle was having all kinds of problems and delays and challenges. And this facility here at Michoud and our contractor Boeing did everything they could to make sure that we could achieve this by the end of this year. That was a challenge I gave them. It's a challenge they delivered on, and we're grateful for it. We have made significant strides. It is also true that SLS-2 for Artemis 2 is already under development in this very facility. And of course, as soon as this one moves out of the facility, we need to get ready as soon as possible for SLS-3, which, by the way, we need to negotiate quickly. Let's make sure we're not forgetting that we're under contract for 2. We got to get to 3. But really, why do we need to negotiate quickly for 3? To our NASA team and our Boeing teams. Why? Because we're going to the moon in 2024. We need that third SLS to make that happen. If there is no third SLS, there is no landing. Make no mistake, though, we're going to get the absolute best value for the taxpayer that we can possibly get. And we're going to continue to work on that. Know this. The efficiencies that we're seeing today, because this one is now complete, are amazing. We're seeing in some cases, depending on the different components and parts, we're seeing 25, 40% efficiencies. The throughput of the SLS rocket is going to get significantly greater. And there's activities, people are saying you can see significant improvements in the throughput, which by the way is going to be good because the cost per launch goes down, all of our efficiencies go up. So the efficiencies have been, I think, magnificent, and that's a testament to the Michoud assembly facility and the NASA employees here, but also our prime contractor Boeing and their subcontractors. Can we open up to questions that are not media? Anybody else have any questions?
Good morning, Mr. Administrator. Paul Murphy with WWL TV. Can you just talk about MeShoot in the overall context of the program, how many employees you have here, and whether you expect that to be a constant workforce or is a workforce that you expect to grow over time?
So it's a great question. I'll tell you the history here is magnificent, going back to the Apollo program, the Space Shuttle program, and now the Artemis program. As far as the number of employees, I'll let you come up and share the information. But I will tell you, this is going to be a very healthy facility for a long time to come because this is America's rocket factory and America needs its rocket.
That's very true. As far as employees for the SLS-1, Boeing's got on the order of 600 here. We got Lockheed that's got on the order of 300 here. We also have other tenants, USDA and Coast Guard. So on any given day, there's about 2,500 employees on site here on the NASA facility.
So a lot of our contractors actually lease the facility and then they enhance it. So it's actually a benefit to the American taxpayer. It's a good program for us as an agency. We're going to do one more question. All right, one more. It's got to be somebody. This is the most shy I've seen a NASA audience in a long time. All right.
Hi, Paul Brinkman with United Press International again. So this facility itself was not flooded during Katrina, but the property was surrounded by water, and many NASA facilities do have some vulnerability to sea level rise and climate change. What is your take on what that looks like going forward and how NASA deals with that?
Yeah, it's a challenge. The way NASA is functioning right now with its budget, we're putting our resources towards capability that delivers space exploration initiatives. And sometimes the infrastructure falls behind because of that. And we put a huge amount for that kind of infrastructure in the budget request that is being considered by Congress right now, the 2020 budget request. The bills that come out of the House and the Senate, though, don't always match the infrastructure requests that we have. But you're absolutely right. I've seen this facility where parts of it are underwater because we have a leaky roof and we've got an old facility. I mean, this facility has been around for a long time. Make no mistake, it's plenty capable and it's going to deliver capability for many years to come. But we do have infrastructure needs. We address them as needed, but we need to make some significant investments. And of course, any help we get from our appropriators and our authorizers to achieve that, we're grateful for. But we did put a big request in for the 2020 budget request. We need to get that appropriation complete. Maybe we're not going to get everything we were hoping for, but it'll make a good step towards fixing a lot of the challenges that we have. So thank you for the question. All right, I'm going to close this out here. This is an amazing day. We called it Artemis Day. We're celebrating the core stage of the SLS rocket complete. And I want to frame for you kind of what this means to us as an agency and what it means to the United States of America. I will tell you, as the NASA administrator, I travel the country. Two things that I hear more than anything else. Number one, everybody wants Pluto to be a planet again, just so you're aware. It's true. I mean, I'm just keeping it real for you. Number two, everybody wants Artemis to be successful. It's apolitical, it's bipartisan. Members of Congress on both sides of the aisle want to see the first woman on the moon. We have an ability to achieve that now for a lot of reasons, not the least of which is the fact that the SLS core stage is complete. Let me share this with you. And some of you have heard me say this before, and I'm going to keep saying it because it's important. I am the first NASA administrator that doesn't have a memory of where he was when Neil Armstrong and Buzz Aldrin walked on the moon. I don't have that memory because I was not alive yet. That is a generational failure. And by the way, we had 6 missions that landed on the moon up until 1972. I don't have a memory of any of them because I wasn't born until 1975. We have to make sure that another generation does not go by where we don't have people living and working on another world. That's what the Artemis generation is all about. That's what this generation is all about. And the Artemis generation is very different than the Apollo generation. We love Apollo. It changed history. It changed the United States of America in a very meaningful way. In such a meaningful way that just this year we celebrated the 50th anniversary of the Apollo 11 moon landing, and we had 500,000 people on the National Mall to celebrate. Apolitical, bipartisan, to celebrate. 500,000 people. As a politician, recovering politician, I can tell you I have seen 500,000 people on the mall before. They're never happy. In this particular case, they were all happy. And they were celebrating this monumental achievement from 50 years ago. And think about where we were 50 years ago, 1969. We had civil rights abuses and civil rights unrest. We had protests. We had the war in Vietnam at its peak with protests on campus. We had the National Guard deploying to surround campuses to make sure that it didn't spill over into the cities. Our country was terribly divided, and yet we could unite around one thing that changed the course of history. And that one thing, of course, was the Apollo 11 moon landing, which continued until Apollo 17. The challenge with Apollo is that it ended. What we're doing now is something that is sustainable. Something when we go to the moon this time, we will not have another generation that goes by where we don't have people living and working on another world. That is our call. That is the purpose of the Artemis generation. That is the purpose of the Artemis program. I will also say this, there's another differentiator between Apollo and Artemis. In the days of Apollo, all of our astronauts came from fighter pilot backgrounds and test pilot backgrounds. And in those days, there were no opportunities for women. Well, now we have a new generation of astronauts. We have a very diverse, highly qualified astronaut corps that includes women. And this time when we go to the moon, we get to go to the moon with all of America under the name of the twin sister of Apollo. And she was the goddess of the moon. So under the Artemis program, we are going to the moon sustainably. And we're going to go with this very diverse, highly qualified astronaut corps that includes women under the name Artemis. I think it bookcases American history in the most magnificent way. By the way, the only way this is happening today is because we've got the SLS rocket complete. Thank you so much for all of the hard work. Thank you so much for all of the hard work to get us to this point, but let's remember this is just the beginning. We are the Artemis generation. We need to name it. We need to claim it. We need to move forward with it. And we need to make sure that everybody is talking about the fact that this time when we go to the moon, we're going to go to stay with a purpose of learning how to live and work on another world so that we can take that knowledge and information to Mars. Thank you so much for being here. Happy Artemis Day.